We live in a time of global transformation. The Energy Futures podcast explores how we can accelerate the expansion of clean energy technologies and reduce our reliance on fossil fuels. From heating and cooling our homes to moving around our planet and beyond, we bring together researchers, scientists, business leaders, and communicators to exchange knowledge and try to answer one important question. How can we create a sustainable energy future for all? This podcast is produced by Energy Futures Lab of Imperial College London.
What alternative storage technologies are there to replace batteries? And can these technologies hold up to the growing demand for green energy? Today's episode is hosted by Dr. Nadine Moustafa, a research associate at Imperial College, specialising in carbon management and decarbonisation technologies. Her guests today include Dr. Matthias Mersch, a research associate in the Clean Energy Processes Lab at Imperial. His research focuses on optimal decarbonisation pathways for integrated regional and national energy systems and suitable policies. They are joined by Alexandra Welp, a research assistant and PhD student at the University of Duisburg-Essen. Alexandra has a background in mechanical engineering and is currently a visiting researcher at Imperial, focusing on thermodynamic storage solution technologies. During the episode, they will discuss new technologies that exist outside of batteries and the efforts research and industry are making towards decarbonisation, differences between industrial and domestic energy storage, and the challenges each type of technology brings, and developing trends in the energy storage field.
Welcome everyone to today's episode on Energy Futures podcast, where we will be talking about energy storage beyond batteries. I'm Nadine Mustafa. I'm a research associate at Imperial College London. I'm based both in the Chemical Engineering Department and the Centre of Environmental Policy. And today I'm joined by Matthias and Alexandra, and I'll let them introduce themselves if that's okay. Alexandra, do you want to go first?
Yeah, sure. Thank you very much. So thank you very much for inviting us. My name is Alexandra Welp. Originally, I'm a PhD student in Germany, and I'm investigating pumped thermal energy storage, or in other words, Carner batteries. And actually, there's a large research interest in this field right now. So we are about 20 universities in Germany investigating this field on a bunch of different levels. And I think this is what makes it this is what is making it exciting.
Thank you, and it's nice to have you here. Matthias?
Yeah, thanks for inviting me, Nadine. So I'm Matthias. I'm based in the Chemical Engineering Department here at Imperial. I'm working in the Clean Energy Processes Lab with Professor Christos Markides, and we're essentially doing all sorts of different energy system modeling. So my personal research is sort of at the interface between technology modeling and technology optimization, where you kind of optimize the design and performance of individual technologies, and then at the same time, I'm working at the sort of whole country level energy system optimization and kind of look at how do we best deploy technologies and what roles the different technologies play in the energy system transition.
Yeah, and I think the systems thinking of how to deploy decarbonization technologies is quite important. But while I have you, I just want to ask first to maybe introduce what other major categories exist beyond batteries. So when we talk about energy storage, I think batteries is the first thing that comes up to mind, but there's a lot of other categories. So maybe do you want to kind of expand on that?
Yeah, sure. I mean, you're right. Batteries are sort of the natural thing that everybody thinks about because everybody has them at home and uses them for their devices and stuff. But actually, when we look at the whole energy system and we're talking about big scale, there's a lot of different storage technologies out there. So the sort of easiest thing to do potentially is just to store heat. So there's something like thermal energy storage. This can be, just your hot water tank at home, for example. But then we can also do this at bigger scale. Then there's stuff like mechanical energy storage. So you have, pumped hydro storage, for example, or you can do gravitational energy storage. You can do flywheels, any sort of mechanical energy that you then convert back into electricity. And then there's something called thermo-mechanical energy storage. So you can probably hear from the name, it combines both aspects. So you have this mechanical aspect, right? You have, pumps and turbines and stuff like that. But then you also have a thermal component to it. So you store some or all of the energy as heat, and then you convert it back into electricity. And then, of course, you have chemical energy storage. So you can generate hydrogen, for example, or other fuels, and use that to then store your energy.
Yeah, and I think, I always say this, I don't think there's any silver bullet technology. But just by what you just said, there's a lot of different technologies that exist in this space, of course. And that's usually common within any decarbonization industry or industry that we're trying to decarbonize. Usually there's a lot of different technologies that we can use. And so how important would you say is it to kind of diversify the energy storage technologies that we're going to be using? So having a portfolio rather than focusing on just one.
Yeah, it's a good question. I think it's super important because, as you say, there's no silver bullet, and depending on your application, different technologies have different benefits and different use cases, right? So you're not gonna, right? We're already doing it now, right? You're not using batteries to store heat at home if you take a shower and you have a hot water tank, right? So you store thermal energy. But then you can also look beyond just your home. You can talk about different applications in the energy system, right? You have different electricity storage technologies, for example, but then also you can talk about industrial heating, and you can talk about district heating, where you would be more on the thermal side. And then even if you say, okay, I only care about electricity, I want to store electricity, even there, I think there's a lot of value in diversifying, because each one of these technologies has its drawbacks, and some are only suitable in certain locations, some are only suitable at certain scales, some are good for kind of hourly storage, some are more for sort of interseasonal storage. So there's a lot of value for different technologies. So I think it's good that we're looking into these different things.
Yeah, and I think we'll dig deeper into that when we talk a bit more about systems thinking. But I just want to move back to Alexandra here. And I know that both of you have actually worked on a lot of thermal energy storage. And I know that kind of differs by scale, as Matthias mentioned. So maybe do you want to start by explaining that to us?
Yeah, sure. So I think there are a lot of different options or places where you could use a thermal battery. And then it also depends, what is the purpose that you want to use it for. So I think the beauty of the storage technology is that you don't rely on any particular geographic constraints or on any scarce materials that you need to have, but that you can use, or you can just use relying technologies. For a pumped thermal energy storage, for example, you can simply use a heat pump, which is already investigated, and then combined with a power circle, put a thermal storage in the middle, and then this is your new technology. And I think this is something that it's quite promising to look deep into.
Yeah, and I just want to move back to Matthias and ask how do you envision basically thermal energy storage being integrated into energy systems, especially when you're talking about those different scales that you mentioned, and as Alexandra.
Yeah, it's a good question, because you can either just do it at the household level, and even at the household level, you can do quite a lot for the wider energy system, if you will. You can, say you do have a heat pump at home. You can run the heat pump whenever you have excess electricity, and just store the heat in your thermal store, for example, at home, and essentially use that to deal with congestion in the grid and demand peaks and stuff like that. But then also, talking about different scales, you can do this at the household. You can do this at for large district heating applications, for example. If you look at in the UK, we don't really do that much district heating. If you look at Scandinavian countries, for example, I think Denmark is always the big poster child for district heating, I suppose. And they have these massive thermal energy stores that come with it, and essentially they utilize them to basically provide services to the wider energy system by shifting the demand and only causing demand when you have availability of renewables, for example.
Yeah, and just by you talking about the different scales and hourly storage, do you want to just explain the difference in terms of energy storage technologies when it comes to hourly versus seasonal, for example?
Yeah, it's so these are two very different beasts, because essentially hourly is sort of I think I would say it's the natural first application that you do. It's sort of the easy, quote unquote, easy thing to do, because you can store your heat at whatever temperature you need it. Right, you run your boiler, you run your heat pump, you generate your hot water, and then 2 hours later you take a shower and you just take water from the tank. Seasonal energy storage is a completely different beast, I would say, because you have to store the energy for such a long time that you're not really able to store it at very high temperatures because your thermal losses are just going to be so high. Right, if you say you store heat from solar thermal energy in the summer, for example, you want to use it in winter, and then you look into your tank in winter and you just have water at ambient temperature. You can isolate as much as you want. You lose quite a lot of the heat. So typically what you would then do for these large scale and interseasonal things is you would store it at a lower temperature. And you would use, something like sand pits or gravel pits or just the ground, boreholes, and essentially you just heat up the ground, and then you would then run a heat pump to recover the heat, which would then run much more efficiently. And I think, if you're really talking about interseasonal storage, so storing from the summer to the winter, I think this is only really the only thing that you can do, because otherwise you're just losing way too much energy.
Yeah, and I think given that you've mentioned heat pumps, I'm just going to go back to Alexandra on that. And basically, do you see that we could couple renewable energy, electricity, with heating systems in a way where we could, let's say with heat pumps, for instance, where we could start looking into indirect energy storage? What's your view on that?
Yeah, so I think it's a very interesting question, because in fact there are both sectors that are super important for ongoing decarbonisation, and there are already efforts where people try to couple both of these sectors. Like before, when you were saying that people are heating up the ground and later on they're recovering the energy back. Right now, I know that there are projects who are using old mines which are flooded by water, and they are heating up this water in summer when they have the surplus energy from renewables, and then in winter they discharge it again for district heating. So this is something that it's quite obvious to do. But what they are also trying today is if they could actually use this thermal energy to then produce power at the same time. So not only have the thermal discharge, but also the electrical discharge. And I think that coupling both of the sectors could be a sweet spot, because then, depending on the use case that you have, you're just way more flexible to react to the demand that you're actually facing. Yeah, on the other hand side, people might argue that we need to store the electricity and maybe not the thermal energy. So there are people who are really focusing on the electricity part and try to push the efficiency to the maximum level that we can possibly get.
But I think the big selling point, sorry that I jumped in. I think the big selling point is it's really hard to find anything cheaper than a tank of water that you heat up. So this is, I think, where the whole which is sort of the value proposition of using thermal energy to, as you call it, indirectly store electricity. Because, batteries, but then also essentially any other electricity storage technology can be quite pricey. So if you already have buildings with heat pumps which are essentially equipped to do something like that, then it's an easy win in a way, at least financially speaking, to just make the tank a little bit larger and use some of that capacity, which you get really cheaply, to then store some electricity as well.
Yeah, but then this is what makes seasonal storage so challenging, because then you can run one cycle a year to get revenue out of the system. If you're operating at hour or daily storage, then you can make money out of it each day. So this is what, is quite a challenge for the seasonal storage that you mentioned before.
But my main question is, what are the unique challenges that you've seen when it comes to basically employing any of the energy storage technologies within residential or industrial applications?
Yeah, so I think for residential applications, the pure thermal energy storage wouldn't be the challenge. There the challenge would be if you would like to convert this thermal energy back into electricity. Because for that purpose, you would then need to have a power cycle at home which would be rather expensive and probably not efficient at all. So I think this idea of converting the thermal energy back to electricity, this is rather something for the grid scale application, or for example, for if you're looking at a industry that are running like some kind of chemical plant and they would like to have an alternative. So this is where you would start talking about this thing. On the other hand side, if it's only like the thermal storage, this is something that can easily be implemented.
Okay, and I mean, I feel like you have something to add there, so I'm going to give the mic.
Well, not really to add, because I think there was already a bunch of good points. But maybe talking about specific challenges for the different sectors. I think for industry, you're often talking about high temperatures. So it depends on your process, of course. If you have something that there's some drying process that is only at below 100 C, then it's fine. You can just use a hot water tank. But if you're talking about really high temperature industrial heat, then you need to sort of find new solutions for your stores and find new storage media, and you need to insulate your stores better because of the higher temperature, you have higher heat losses. But also I would argue in some aspects, in industrial applications are actually easier because the nice thing about industrial applications, they are very predictable, because typically you have a process that just runs flat out, right? It's not doing much, it's not changing much. So you know what your demand will be tomorrow, you know what your demand will be in a week, and you can very nicely schedule the operation of your store. Whereas in domestic applications, your demand depends on the weather, for example, and how many people are at home and stuff like that, and you never quite know when somebody's going to take a shower. So it's much harder to schedule, it's much harder to control the store and fully utilize it, because you don't want to end up in a situation where your store is empty, but then you need heat. So this is why I think industrial applications, even though technically they might be a little bit more challenging, but then on the control side and on the kind of scheduling and planning side, they could actually be much easier.
So there's a lot of different things you need to consider. So scale, where is it distributed? Is it centralized? And I know we talked a bit about thermal energy storage. There's obviously other energy storage technologies, as you mentioned in the beginning of the episode. So, for example, if we're going to talk about mechanical, chemical, or maybe gravitational. So maybe, Alexandra, can I start with you, and maybe you could walk us through chemical energy storage?
Yes, of course. Like chemical energy storage, the idea is quite nice, because what we're doing like right now, or what we have been doing the last century, is actually taking gas or oil or coal from the ground and burning it. And what we take out of the ground, it is basically a chemical energy storage, because it has been stored there for centuries. And one alternative might be that we take the surplus energy that we have from the grid, from renewables, we convert that to chemicals, which could be hydrogen, also like other e-fuels that could be used for aviation. And then, so these fuels can then be stored for almost unlimited amount of time. So this is a nice opportunity for seasonal storage. And then when you use them, you can just like burn them again or convert them again in the way that you needed to. And then you get the energy back out of it.
So the advantage is that you would treat them the same way-ish as what we do now with fossil fuels.
Yes, and especially if you think maybe about cars, like right now, so at least in Germany, there's this debate whether one should go for the electric cars or whether one should focus on the e-fuels. And there are people who don't want to change maybe the habitudes, and they don't want to charge the cars for half an hour or an hour. And then these people might say, okay, yeah, but an e-fuel, it would just be like super practical, because I can still like put it in my car, start driving. But then as Matthias said in the beginning, each of the storage alternatives has its own advantages and disadvantages. And this is also where it comes in with chemical storage. Like these chemicals are not produced out of nowhere. So you're also going to have like losses on the way to produce the chemical, and then also on the way to convert it back. So you are not getting 100% out of it.
Yeah, you're losing some efficiency on the way there.
Yes.
And it's interesting that you say, maybe the public wouldn't want to change their behavior, because even though a lot of the time in those podcasts, at least with me, for instance, I've been joined with like engineers and scientists, and our work is pretty much modeling or lab work, for example, it always comes up like, how will the public react to this? And it's not maybe something we think about on a day-to-day basis when we're doing our work, but it's nice to hear that, we're getting a lot of exposure to other stakeholders that, inevitably we're all going to be involved in this global net zero target, right? And we need to get the general public in with us, the policymakers, industry, and everyone kind of just working together to get there. But yeah, it has come in every single episode where we go like, okay, how are we going to do this? And maybe Matthias, do you want to continue and talk about mechanical, maybe gravitational?
Yeah,
Any
sure.
other technologies you want to talk about?
I love talking about technology, so I'm very happy to. So maybe mechanical. Mechanical is sort of the traditional electricity storage, if you will. It's probably the oldest form, maybe together with batteries, but so the simplest form of mechanical energy storage and the most common one is pumped hydro storage, which I think most people are familiar with. Is essentially the idea you have a lake on top of a hill, you have a lake at the bottom of a hill, you pump water up the hill using electricity, and then you let the water flow down again to run some turbines and use that to store electricity. And in principle, it's an amazing technology. It's comparably cheap. It's very reliable. It's quite efficient. The big issue is you need a suitable location to do it, and it's obviously quite invasive to the local ecosystem because you're building these dams, you're creating these artificial lakes. So you're quite limited in how much more of that you can do. Other alternatives that people have been thinking about, there's, the gravitational energy storage that you mentioned. I think there was this one project in the US that I can think of where they were essentially pulling trains and train cars up a hill and then let them go down again, and we're using that to store electricity. And essentially, a lot of it is about, increasing the potential energy of something, lifting something up or pumping something up a hill and then letting it come down again. Other examples of mechanical energy storage are things like flywheels, which are quite different, both in their design and also the function that they fulfill in the energy system. Because these ones, it's essentially a very fast spinning disk, which is used to store relatively small amounts of energy, but is essentially stabilizing the grid because you have the large spinning mass, which will then keep the grid at its frequency. And whenever the frequency drops, then the flywheel will compensate for that.
Yeah, and based on what you just said, because I know, for example, any different technologies, there's different technology readiness levels, for instance. And so what would you say are some misconceptions between the different energy storage technologies, maybe some that might be overhyped, or do you have a favorite yourself?
Yeah, my favorite, I haven't even really talked about them. Well, I'm not sure it's my favorite, but the other type that you have is the thermo-mechanical energy storage one, where you have something like compressed air energy storage, where it's essentially a gas turbine process that you cut in half. So you have the compressor on one side, you run the compressor, you compress the air, but then rather than immediately expanding the air, you store the air. And then in sort of the modern applications, you also store the heat, because when you compress the air, it becomes hot, so you store the thermal energy. And then whenever you want to discharge, you pump, you let the air, you guide the air through the thermal store again, it heats up, and then you expand it through the turbine and you get your electricity back. And then there's also other flavors of this thermomechanical energy storage. There's the pumped thermal energy storage that Alexandra already talked about, and that our research project is on, where again, you run a heat pump to store thermal energy, but then you run a heat engine to convert it back into electricity. You can do something called liquid air energy storage, where you take the air, you compress it, but you also liquefy the air, where the benefit is that you store a liquid rather than air, because the issue with compressed air is you need these massive volumes of storing the compressed air, whereas if you liquefy it, you have a much smaller volume. And then you use both hot and cold energy to then discharge the store again. So yeah, different flavors. Maybe not my favorite, but the one I worked on the most is compressed air energy storage. But again, it's quite promising, but you need the right location and you need this large storage volume to be available. So yeah, to answer your actual question, sorry, I've been rambling on about different things here. So misconceptions, I think it is very hard to understand just the scale that you need. So, for example, if I go back to pumped hydro storage, it's essentially an entire lake worth of water that you pump up and down a hill, and that gets you maybe a couple of days of storage. So, things like the gravitational storage, where you have some train that you pull up a hill and then let it run down again, you just don't get anywhere near the scales that you need. And then I think Alexandra also mentioned a little bit about the drawbacks of the chemical energy storage. And I'm not sure if it's a misconception per se or just a challenge, but yeah, as we said, in principle, the idea is great. People don't have to change much. We don't have to change our energy conversion technologies much. We can just use this clean fuel for everything. And there was a while where hydrogen was sort of seen as the silver bullet. And then people started looking into it, and yeah, actually is really quite inefficient, because you go from electricity, you have losses when you generate the hydrogen, you store the hydrogen, and then you have conversion losses again when you go back to electricity. So I think people tend to underestimate how much energy is getting lost in the process, and the argument is always, oh, we have surplus renewable energy anyway, so it doesn't really matter. But there's only so much energy, and you want to get as much back as you can.
And just based on that, because you were talking about how we have, yes, it's surplus energy or surplus electricity, but it's a finite amount. It's not infinite. And so from a systems perspective, I think, which is something that it's quite important to think about it from that perspective, right? To think about the whole system and what happens there. And I know you do a lot of energy systems modeling. And so from a systems perspective, how do you see the different energy storage technologies playing a role within the energy system?
Yeah, so I think different technologies play different roles. I've probably repeated this a couple of times now, but so you have, and many or all of them are important. So you have things like the flywheels, for example, or super fast acting capacitors and stuff like that, which are really, within a second or millisecond range, essentially stabilize the grid and make sure that the frequency stays where it's supposed to be. And then you have a range of technologies for sort of day-to-day or inter-day storage, where essentially the idea is, for example, if you have a lot of solar energy in your system, you charge your store during the day, and then you discharge your store during the evening, peak, or overnight. So it's this, anywhere between, a couple of hours to maybe 12 or 24 hours. And this range you have, batteries, of course, but then also a lot of the thermo-mechanical energy storage technologies that we talked about. And then the big challenge is if you then try to do interseasonal energy storage or long duration energy storage. And the scenario that many people talk about, and I know it's very big in research as well now, is the Dunkelflaute. So it's essentially times where you have little solar energy and very little wind. And this can be, if you look at meteorological data, this can be, a couple of weeks. Mm-hmm. And essentially, if you wanted to run an energy system purely on renewables, you would have to make sure that you have enough storage capacity to also cover this worst case, because it's not an option to just let the lights go out. Essentially, we've just seen this in Spain and Portugal, what happens if you have a big blackout. So it's not really an option. And for that, and and I know this podcast is beyond batteries, but I think you're going to struggle to get this done with batteries just because of the sheer amount of energy that you need. And then I think you need to talk either about some of these very large-scale thermomechanical solutions, or you need to go towards something that looks like hydrogen or chemical storage.
And I mean, I just want to highlight that this episode is beyond batteries purely because we did an episode on batteries. It's not, I mean, as you said, like all of them have advantages and disadvantages.
Absolutely,
And I mean, Alexandra also pointed that out. And I say this all the time. And I think if anyone's bored of hearing my voice saying this, but there's no silver bullet technology. And so it's purely beyond batteries just because we have another episode.
Exactly. Yeah. No, it's not at all my intention to discredit batteries or anything. No, as you say, it's different things for different applications.
Yeah. And I think I mean, can I ask you the same question? Is there like a favorite within your? I mean, it could also be the fact that just because you do a lot of work on thermal energy storage, then that's your favorite.
Yeah, so I mean, of course, like my heart beats for the counter battery. But now to be realistic, I think I'd rather go for the technologies that are not like in the media every day. Because as you said before, it's all about the policy and people needing to accept a new technology. And if then the media or the policy is only focusing on 2 or 3 things, maybe this is not going to be the best alternative, but just the closest. So I think that I would go for like all of the other alternatives that are out there, but maybe go beyond the classic battery.
So the ones that have a lower technology readiness level and more innovative and probably trying to scale that up.
Yeah, maybe it's a bit this, yeah.
Is there anything in mind that maybe you're working on right now?
Yeah, so of course, like we are working on the pumped thermal energy storage, and what's so amazing right now is that they're actually the first power plants or the first devices that are actually being built right now. And I'm not talking about lab scale demonstrators, but I'm talking about facilities that are actually being integrated into the grid. And like being able of participating in these things and doing research in these fields, this is just amazing.
That's really interesting. And just to clarify, that's what you both mentioned when you were talking about thermo-mechanical energy storage systems, so kind of having a hybrid system of some sort. Do we see that elsewhere in the energy storage technologies, like hybrid technologies?
Yeah, I think there's some applications, mainly the ones that we've talked about, where you try to integrate different types of energy storage. So you store some of your energy in the form of heat, and the other as pressure, for example, or some sort of mechanical. I'm not sure, because something like batteries, so I'm not sure they naturally integrate with any other technologies. It's sort of, at least in my, opinion or limited knowledge, it's sort of its own thing. It's self-contained, which I think is also one of the benefits in a way, because then you only have to deal with one thing. I know that people are thinking of combining chemical storage with some of the other ones, because again, if you have hydrogen production, for example, it's a very energy-intensive process. So if you combine that with some sort of thermal integration and thermal stores, then there's some potential, but it's sort of, I think it's more at the conceptual stage for now, because typically, and I'm a researcher, so I'm maybe a little bit far away from what's actually happening in reality, but from my understanding, companies like to solve one problem first, and they have expertise in one area, and then if you suggest that they also go into this totally different field, then it becomes difficult, because then they don't have the expertise, they don't know the risks associated with that, and it's sort of solving one problem first before trying to tackle 10 at the same time, and I think that's fair enough.
Yeah, and I mean, we talk a lot about this in terms of like the risk appetite, and should they be investing in things that are a lower technology readiness level, and so higher risk for them. Are they going to be getting revenue out of this or not? But speaking of innovations and trends and breakthroughs, is there anything that you're excited for within the energy storage field? And that'll be I think, my last question, unless I have follow-ups. But is there a trend or a breakthrough that you're kind of excited for within the energy storage field?
I think something that I would be excited of is really seeing these applications coming to life, and then seeing that actually the part in the electricity grid is that high that we actually see like a certain percentage point which is then covered by electrical storage. This would be great, because this will then prove us that what we're doing is working on a large scale, and that this path to net zero is realistic, and that we are getting closer.
And if you have that magic wand to have one energy storage solution just deployed massively, which one would that be?
Of course, the one that we are researching in. I mean, this is what I would go for.
Okay, we'll go with that. Matthias?
Yeah, I think things that I'm excited about, and I think this is something that we should potentially mention at least once in this, is, and you mentioned it just briefly, it's the revenues. Like, you need to make it work financially, because otherwise you're not going to be able to attract any investment. And I think it's maybe exciting that now people are talking about this issue, and people are looking into how can we design markets and what are potential applications to make energy storage work. Because essentially, so first of all, if you're really talking about the long-term interseasonal storage again, it's really difficult to make a lot of profit, because you're only discharging once a year or twice a year. So, you have this big asset, lots of capital tied up in your asset, but then you have only very limited, at least the way the markets are currently, you only have very limited opportunity to make any profit with it. Day-to-day stores are in a little bit of a better situation, I think, because they can, essentially participate in the energy market daily and, make use of price differences between the evening peak and, the midday, where you have maybe a lot of solar generation, very cheap electricity, maybe even negative electricity prices. But even then, it's difficult. And the other issue is that the more energy storage you have in the system, the smaller the price differences become, because you have all the stores kind of balancing out the electricity system. So in a way, by deploying more capacity, they are jeopardizing their own market in a way. And I know there's a lot of talks in the beginning. At the moment, I'm not really an expert on any of this, but I know that there's a lot of talk going on how can we design markets that work also for energy stores.
You'll be happy to know that we just did a financing decarbonisation episode.
Oh, fantastic. Yeah.
It wasn't on energy storage.
No, but I think it's true for a lot of technologies. And essentially, with the energy system changing, I think the way the market works also has to change, because it's not the traditional, I have my big coal plant or gas plant and I sell electricity whenever somebody wants it. And you need sort of different sources of revenue potentially for the energy stores to work. So yeah, I think it's exciting that people are talking about it. And if I do get my magic wand as well, I'd probably change the market and design it.
Okay, so asking for business models rather than an energy storage technology.
Well, so because the thing is, the technologies, I would argue, are ready to go. As in, it's not something that we've just drawn up on a piece of paper and something that's still in very early stages. Right? We've got pilot plans. Most of them are sort of established components, and they just need to get scaled up essentially and make it out of the pilot stage into actually commercial applications.
Yeah, and I mean, I agree. And I think on that note, I'll end this episode saying that this is where basically policymakers, industry, academia should be working together to get to that doing stage. So we've done all the research, we have the technologies, we need to start scaling it up. We need to start building those business models, reducing the risk for financiers, and make sure that we can scale all of this to reach our net zero targets, hopefully. And with that, thank you so much for having you both today. And thank you so much for listening.
Been a pleasure.
Thank you.
Thank you for tuning in to the Energy Futures podcast. Here at Energy Futures Lab, we are dedicated to addressing global energy challenges through pioneering research, innovation, and advocacy. To learn more about us and the exciting projects we are working on, visit our website and follow us on social media. If you enjoyed this episode, please like and share and subscribe to stay up to date with our latest content. Until next time, stay curious.